Well, thanks everyone for coming out. Thanks GDG Reading for putting this all on. I'm really excited to be here. Let's talk about augmented reality on the web. So I'm Doug. I'm originally from Seattle, Washington, but I've been a digital nomad in Europe for the last 4 years with my family, just traveling about and exploring. I used to work for a small telecommunications company in America called AT&T. Some people get the joke, some people don't. When I decided I wanted to travel around Europe, they said that I couldn't travel around Europe and still work at AT&T, so I do freelance developer relations now. I help companies figure out how to talk to developer communities. I help companies, figure out how they're going to do that. I got started on this doing performance, and so I know there are like we learned earlier today that there are about 7 Android developers in the audience. Seeing as there are people in other rooms, there are probably 3 right here, right now. If you're interested, I wrote a book on how to speed up Android apps. The Fern isn't blocking it. That's the link to the PDF, so if you want to download it, you can just download it for free. That's cool. I got started doing performance, so making websites faster, making native apps faster, because if apps are slow, if websites are slow, people get frustrated, and if people get frustrated, they stop using your app or your website, and they spend less money. So if you're building an e-commerce website, like, performance is important because you want people to spend money so that you can keep your job. So I do a lot of stuff on workshops on performance, images, and video becoming an emergent part of the web and mobile platforms. And today I'm going to talk about AR, and then later this afternoon we're going to play around with the stuff I'm talking about today in a workshop. So if you're interested, we can pull out our laptops and build some AR. I'm the only Doug Sillars on the internet, so if you want to reach out to me, I'm pretty easy to find. And I'll post these slides up on Twitter and all of that later this afternoon. So let's get started. Virtual reality, you start thinking about virtual reality, you're building sort of this 3D realm that you can explore virtually, right? And so this is just a GIF I pulled off the internet to try to say what that looks like. You kind of do it with something like this, where you grab a smartphone and you pop it into a device, and you pull it over your head, and all of a sudden you're in a 3D world. And this is really, really cool. Again, this is not something that you're like, ooh, a virtual reality experience, right? You pull that out of your bag. No, this is something that you have at home or you have in your office. It sort of limits how you can interact with virtual reality because people aren't carrying these things around with them all of the time. The great thing is there's 3,000 of these VR headsets on Amazon. And this screenshot's a little old. That number may be bigger now, like the holiday season's about to ramp up. It's probably like 10,000 now. And they're cheap, right? You can get one of these things for, I think I got mine for like 13 pounds, right? And I didn't get a cardboard. The Google Cardboards are even cheaper, but I travel a lot, and I just knew that thing would get smashed because cardboard is not, plastic will break, but it's held together. Plastic. So these things are really affordable. It's really easy to get into it. It's really easy to build an audience because this audience exists. You start talking about augmented reality. Did anyone remember these? Google Glass? Did anyone wear Google Glass besides me? A few of you. Best sunglasses I've ever owned. I could get my tweets up in the corner, right? I mean, this was awesome. This is 2012. This is sort of the beginning of augmented reality, right? I could get my email in my, in the periphery of my vision. I really enjoyed wearing them. Again, the best sunglasses I've ever owned. But people started giving you the side eye because there was this whole thing about maybe he's recording me. Is he recording me? And what Google didn't want you to know is if you were recording video with Google Glass, you had approximately 90 to 120 seconds of battery life, right? There are these 2 little watch batteries in the back. And so was I recording you on video? No, because I wanted to get tweets in my, in my periphery. So anyway, that's the beginning of augmented reality. Now we've got things like the HoloLens. Anyone here played with the HoloLens? Can you be a little louder? I've never had anyone in my life tell me to be louder. But that's awesome. I will be louder. So who's played with the HoloLens? These are really, really awesome. They're really cool tools, and you get like this overlay of, an augmented, you get virtual stuff augmented, it's overlaid on your reality. It's super cool. I've seen some really cool applications built for this of people building awesome tools. The trick is, of course, these cost $3,000. So like hardcore gamers, enterprise solutions, yes. The average person on the street? No. So if you want to build augmented reality and you really want to engage a large audience, like HoloLens isn't there yet. Like probably someday this is something that's going to be around that everyone can use. What I don't want to say everybody has, but a lot of people have are smartphones, right? There are billions of smartphones out there. And if you can build augmented reality in a smartphone, all of a sudden you've got an audience, right? You don't have to wait for everyone to shell out $3,000 for this thing that they're not carrying with, right? Again, you've got this, right? People aren't wearing this on the street because they get funny looks. Yet. I mean, someday this will be normal, right? Maybe. Maybe they'll just look like regular glasses and we won't even know. But, you know, probably everybody here has a smartphone because we're all developers and stuff like that, right? So, like, why don't we start building augmented reality in a smartphone? Because we can do that. Of course, you have to say Pokemon because augmented reality in a smartphone, everyone starts thinking about Pokemon because here I am in my front yard and Krabby's on my front lawn, right? Little side note, remember this app crashed all the time when it first came out? Like, it was just awful and it crashed all of the time. This is sort of going back to Android and Android performance. The reason it was crashing all the time, I was working at AT&T at the time, and everyone flipped out at the carrier because everyone was using Pokemon Go and everyone was complaining that it didn't work. And we're like, oh my God, is it the network that's breaking Pokemon Go? And the same thing was happening at Vodafone, and the same thing was happening. Everybody was freaking out, like, what's going on? It turned out that this application had a bunch of APIs going back to the main server. Where's Doug? Where are the Pokemon? Where are the nearest gyms? Right? All sorts of, there were like 6 APIs firing back and forth. And rather than using one IP connection, one IP port connection back and forth between the phone and the server, each instance of the app was firing 5 or 6 IP port combinations back and forth to the server. So if you had capacity for 6 million connections, that's not 6 million users, that's 1 million users. They were essentially creating a denial of service, a distributed denial of service attack from their app against their server. And so that's why it was crashing all the time. You'd catch a Pokemon, but your IP was no longer fresh. Somebody else would grab that IP and be like, well, I just caught the Pokemon, but it would crash because it couldn't identify who had actually caught the Pokemon. So be careful about that. That's an architecture, like going back to the last talk, and then going back a little bit further, Android performance. Like, you have to think about these things. If you can reuse connections and you go viral, you're probably not going to crash your system. So back to AR, VR. Let's talk about what we can do today, because we can do this in the browser today. And, you know, AR apps, VR apps are awesome. But the great thing about doing this in the browser is the techniques I'm going to show you today run on every iOS device from, I think, the 6 forward. And it runs in Android from Android 4 on up, or maybe 4.1 on up, right? So that's like 95%, like it's a huge amount of, it's like 99% of iOS and like 95 or 98% of Android users can do this today in the browser. So that's really cool. Then I want to touch on what's coming up soon, because that's really exciting as well. Anyone here played with A-Frame? A-Frame users? Okay, I know there are not a lot of Android developers. How many people have built a web page before? Yes! Awesome. So A-Frame is from Mozilla, and I know I'm a Google developer expert, and I know this is a GDG, but this is Mozilla. That's all cool. We're all good. We're all friends here. Check out aframe.io, lots of tutorials. I'm going to walk through some of this here today, and then we'll do a workshop later. And then all of the examples I'm going to show you are up on GitHub. So again, we can play with those later today. You'll see the examples here. All right, so HTML. Like, everyone raised their hands, so hopefully you have an idea of what HTML looks like, right? When I built my first web page, it was a Notepad on it wasn't even, it was before PowerPC, because I'm dating myself, right? But it was a really old Mac, right? So, you know, you've got some HTML, you've got a header, you've got a body, right? This is all very simple. This is A-Frame, and like, I've never counted the lines, but like under 15 lines of HTML, right? So the first thing we do in the head is we add the script for A-Frame, right? It's a JavaScript, we have to add that. And then we add a scene, and it's an A-Frame scene. It's just in the body of your HTML. And inside that body, we add a bunch of stuff. So I've got a box, a sphere, a cylinder, a plane, and some sky. And there's positions. and rotations, radius, and colors and stuff. And so we'll talk about what we're doing there to make this work, but let's just see what it looks like. And let's see if I set this up right. I didn't, so of course I didn't. All right, but this is the web page. This is what it looks like. See, I've got a sphere and a cylinder and a box and a plane, and it's a web page. I'll reload it. I already had it loaded. Pretty fast to load, right? We're talking, one JavaScript file and, a very small HTML file. And, with your arrow keys, you can walk around. And it's 3D, right? We can position ourselves and walk around, and, there's no gravity or geometry here, so you just walk through stuff. But you can see like we're moving around through this world, and I think that's super cool. And we're going to talk about all the positions and stuff. So if you notice, all my positions here are negative in the Z direction, the Z direction. I'm American. I'm sorry, in the Z direction, because positive Z is behind us. And so negative is through the screen. And so if you want something to be in front of you, you have to make it a negative value. So there's some tricky little things. The great thing is this is all HTML, so if you make a change to your page, you just hit, Command R, and you can see what happened on the browser to see if you fixed it. It has developer tools, so you can move things around as well if you're into that. You can rotate stuff, like the sphere. I decided how big it was by changing the radius. I can change the colors, all that fun stuff. All right, but we want to build an art gallery. And so to build my art gallery, what I am doing here is I built a bunch of walls just by making planes, right? Big rectangular shapes, and I make them into a box that then we can walk into. And so we can see what that looks like. Make you go away so I can't find you later. All right, so, I put the hello world in a box, right? And so now we're in a room that is the beginning of our art gallery. Now, fun stuff about the way A-frame works is you have to define the color of each side of the wall. And I didn't define the color of the other side of the wall, so it's invisible, right? So I can make, whoops, right, it disappears because I didn't define the outside color of the wall, and there's no physics, so I can walk through the wall, right? So we have to think about all of those things. But I built a room, right? So we're building an art gallery. The next thing I want to do is I want to put some art on the wall, because it's an art gallery. So what I can do is I can go to Wikipedia and I can download a picture of Scream. There was a tweet the other day. Did you guys see this about how Scream was really just a picture of a spaniel? And so the hands are the ears of the spaniel. Anyone see it? Once you see it, you can't unsee it, and I apologize for that. Maybe he was just trying to draw a dog and he wasn't very good at it. So what I did is I post an image. I have it hosted at Cloudinary. It's just a cloud hosting of images. I give it an ID of Scream, and then when I have a box, I just give it the source of Scream. And so what that does is it puts Scream on all 6 sides of this box. So this is the box. It's got a position of -4, again, so it's in front, right, in the Z direction. I put it 2 meters up because you don't put priceless art on the ground. And then how did I come up with the size? A-frame is all measured in meters, and according to Wikipedia, it's 91 centimeters by 73.5 centimeters. So we're going to go realistic, and we're going to make it that size. I gave it a little thickness so you sort of get that 3D effect, right? And so we can see what that looks like. Right, there it is. And we can walk around it, and we can see that there's art on the other side as well, right? It's just on all 6 sides. The next slide shows that I can animate it. There's a way to animate things that you have in A-frame, so I'm going to make it rotate here so you can actually see that it's actually on all the sides, right? You can see that what it's actually doing on the top is just smashing it down into a tiny little, it's not actually, it looks like it's sort of wrapped around, but actually it's just smashing Scream on all 6 sides. And so to add the animation, there's an animation tag, I want it to rotate, I want it to autoplay. take 5 seconds, and go around all 3 axes 360 degrees. Like, this is pretty basic stuff. It's all in the documentation. It's easy to figure out. You wouldn't do that with art, but I just want to show that there's fun things you can do. All right, so now, like, I showed you a room that had one piece of art on it, but, you know, this is all virtual. We can do whatever the heck we want. Why don't we add the Mona Lisa, some Picasso, Starry Night, and Michelangelo's David all in one room, right? That's never going to happen in real life, but we can make it happen in virtual reality. So let's do it. A-frame room, art 2. Right? And so those are all real size. Like, everyone jokes about the size of the Mona Lisa being really tiny. You go to the Louvre and there's like this giant room and there's like 20,000 people in the room. I'm exaggerating, and everyone's queuing up to see this tiny little piece of art on the wall. These are all really small, right? We can get up really close. We can get closer than the guards will let you in the Louvre. No alarms. Oops, I walked through it, right? But you can see these are all actually really small pieces of art. The Picasso's over on this wall. And in this case, this is in the Prado in Madrid, and it's 5 meters wide. I actually had to make it smaller to fit in my room. This is something you can't do with real art, right? Like, people get really mad if you, right? You can't do that. But then I was thinking, like, if I'm making art smaller, why not make art bigger, right? We have a high res, you know, a very high resolution JPEG of this image. We can actually look at it and get really close to this much larger version of Starry Night. And, you know, we can get up really close again and see all of the detail in sort of this virtual world, which I think is super cool. And then behind us, this is sort of the not safe for work part, because, you know, David, right? He's a priceless work of art. But he is. And this is a GLTF model, which is a standard model for 3D objects. So if you build something in Blender or any other 3D modeling software, you can export it as a GLTF, and then that can go straight into A-frame. And you can download these from all sorts. There are all sorts of websites, just like there's image websites. There's sites that have GLTF models, and I got David here for free. And you can walk through David, but my head, as I'm walking through, is in a very, you know, inappropriate region for me to walking through it in front of a public group of people. It's rather embarrassing. He is hollow, though, so if you go inside and look straight up, you can see right into his head. But so again, what I did is I've got 4 images here that I've got that I reference, and then in this case, it's an item called David, which is the GLTF model. And so here I've got the first wall. That's the second wall with the Picasso. Here's the third wall with Starry Night, bigger, right? I just changed the scale of the image. And then finally, instead of a box, it's an entity for the GLTF model. All right, so then I thought, well, if you look at this room, like, it's got this kind of boring ceiling, so I wanted to go big with my ceiling. And so, you know, we can do whatever we want. It's a virtual world, so, like, if you're going to add a ceiling, you should add a ceiling, right? And so I added the Sistine Chapel to the top of my... I had to actually lengthen the room to make it fit. Oh, oops, there. Yeah. Incidental, but you, yeah. Anyway, so there we go. There is Michelangelo's David in the Sistine Chapel. Again, something that'll never happen in real life. So again, Sistine Chapel image from Wikipedia. I apply it to a cylinder and then only display 180 degrees of the cylinder. That's the theta. So pretty straightforward stuff, pretty cool. So GLTF models, I mentioned, these are great. Just like when you take a photo with your camera, right? We always have our phone set to the highest resolution. But you don't want to put a 16 megapixel image up on the web because it's going to be like 5 or 6 or bigger megabytes, and that's crazy, right? We always resize the images to go on the web. If you're interested about that, I've given talks on that, actually, I think at GDG Reading about a year ago. So I think there's probably a video. Or we can talk about it later. I'll be around. But GLTF models are the same way. You've got something up in Blender or your favorite 3D modeling, and you export it. It's going to export it at the highest possible quality that you can get. And then all of these services have this super high quality version of this model. you don't want to just go throw that up on the internet because it's going to be a really big file. And as an example, David weighs in at about 25.5 megabytes, right? That's a little bit big to be putting up on the web. So the way GLTF models work is even if you just have a GLTF file, it's a zip file, so you can rename it zip and open it and see what's inside. There's a GLTF file, and that's basically the XML that pieces everything together. The binary file are all the 3D points, and that's why it's 23.9 megabytes. And then you've got a bunch of images that get wrapped around all of the points, and that's how this model is built. So, you know, I'm a performance guy. Like, I don't like having my web page weighing in at 29.5 megabytes. So we're going to talk about performance because I think that's an important thing to think about when you're building web pages. Because when web pages... So I actually came here on the GWR, and the GWR limits you on the free Wi-Fi to 15 megabytes before they throttle you. So you get halfway through this web page before you're throttled. Right? Not cool. So let's go to augmented reality a little bit before we get there. So to add AR functionality, there's AR.js. So I add a second script to my page. And now that we're dealing with augmented reality, we need to start thinking about markers and entities. And it looks like maybe my computer thinks it's still nighttime somewhere, or maybe it's just the weather outside has decided that it's nighttime and I need to. All right, sorry about that. All right, so we have to add cameras, we have to add markers, and so we're going to talk about that here really quickly. So with AR.js, we have this concept of markers. And so now this is the audience participation where you pull out your phone and you enter that URL into your browser and hold it up to the screen, and hopefully the demo will work. And if it doesn't, I've got a fallback. So what this is doing is when you have a marker, and this could be it can be a QR code, or it can be anything that looks like this. It is case sensitive, so A, R, and H all have to be capitalized. But what it'll do is it will find the image. When it finds that marker, it will overlay a virtual item on your browser. And I'll see if it works here. Let's see. It's working on my phone, so hopefully it'll work on yours. It working for anybody here? Yes, awesome. So folks who are doing it, you should see a giant cube with the Mona Lisa appearing on the screen. And so that's pretty cool. This is a sort of thing that, like, if you were running a marketing campaign or something, you could put this on the side of a bus stop, enter this URL, and see what happens. And you could have, like, a fire-breathing dragon or something, right? You could do really cool things. Again, like, I'm not super creative, so I came up with a cube. But you can do a lot more fancy things than just a cube. And for those of you who didn't pull out your phones, Dev Tools, this is my phone. I'll minimize that. All right, so this is my phone. Like, hi, everybody. Oh, come on, you just worked a second ago. So one thing it has trouble with is you can see the reflections. It has trouble with, I'm getting the lights reflected. But you can see that once it finds that, it's adding a cube of the Mona Lisa on the screen. And the size of the cube is referenced to the size of this box, so you can make that cube bigger or smaller depending on what you want to do. So it's pretty cool. Like, there's a lot of fun things you can do with these markers. The other great thing is you can create your own markers. So if you wanted to build your own tooling or whatever, you can build your own marker. There's a website that will build a marker. Again, me being super creative, I took a screenshot of a giant one in a Word document, and I made this a marker. And so when you run this marker tool, it generates two files for you. One is a PNG, right? This, that you can print out. You can print it out, put it on the wall, so it can be a marker. And then it creates a .patt pattern file, and that's what AR.js uses to recognize it in the browser. So you end up with a marker, with a pattern marker, with a URL to the .patt file, and then when it finds it, it'll show the Mona Lisa. Like, it's pretty cool. It's pretty easy. If you have the URL open, You just have to change from hero to ART, and you get a new page. I'll do it here for those who don't want to do it. And then come back to here, right? So now when it finds the one, we get the Mona Lisa on a giant cube. If I move this over, and this is just Chrome DevTools, by the way. Have you ever used the Chrome Inspect, like for remote devices? Super cool. So you can see I've got my DevTools open here. But if I do the picture of me, again, oh, you can see the glare is making it have trouble finding. There, right? Giant cube of me. Because again, I'm not super creative. But it works. The other cool thing is this page has a bunch of different patterns. So one is the, whoa, that's a little close to the Mona Lisa there. We've got the one, we've got the two, we've got Scream. Oh no. Oh no. We'll give it a second here. 3 is the Picasso. And 4, this is actually my favorite. This is the Pigeon View of Michelangelo's David. Right? Only the pigeons ever get to, in Florence, get to see David from the top down. And the reason for that is the base of David is the bottom. And so the idea is you could put that on the floor and you'd have David standing in your room virtually. The trick with this is, of course, you have to keep that entire marker in view the whole time. So if it's on the floor and you scan up to see the top of David's head, it disappears. So like there's some limitations here. But again, this is super cool because, you know, with a little bit of JavaScript, I'm just going to change the URL. I'm just going to load a second page, and I'm going to get different content. But you could imagine doing it with JavaScript. Like every 15th person gets a different file. In this case, or you could imagine if you had an art gallery, these are Beatles covers, right? So I've got Beatles covers with the different markers, right? Sgt. Pepper, right? You could serve different art to different people, to different users by user agents, by what they're interested. You could have an art gallery where one person gets Impressionist art, one person gets Cubist art, right? You could do different things and you can do it all right in the browser, which I think is super cool and fun. It just opens up a lot of different things. You could imagine every 150th person at the bus stop wins a prize, and it just pops up with that they won a prize with a code or something. Like all sorts of fun things you can do. So optimizations, this is a screened video of this page loading on a slow 3G connection. So I changed the DevTools so it was really slow. And you can see, like, we're having trouble with Starry Night. I think it eventually loads, but I get impatient here. Like, it's like watching paint dry. Does it show the video? Maybe it doesn't actually fully load. All right, anyway, you get the idea. Like, it takes a long time for that to load. And so why is this taking so long? Just like that GLTF file is 25 megabytes, that's too big. We need to make our images smaller. The Starry Night is 1.8 megabytes. That's too big for an image on the web. We don't need it that large. So we're going to reduce the file size. Now, one interesting thing is A-Frame is built on top of 3.js. And one of the rules of 3.js is that all images have to be sized to a power of 2. And so in this case, it's taking my image and resizing it to 1024 by 1024. My phone can do that. Our computers can do that. But if we know that every single time the thing is going to download, it's going to resize it, let's just do it once on the server so that not everybody's phone has to do that work. There's a battery cost to that. We talked about battery stuff earlier. I mean, it's not a huge cost, but on lower powered phones, this can take some time. So if we know we need to resize it, let's just resize it on the back end. What's great about the tool that I chose to host my images, Cloudinary, is I can just put height 1024 and it resizes it for me automatically. I don't have to open up Photoshop or anything to do that. It just does it for me. Now, the other funny thing that was happening is that all of my images were downloading twice. So I opened up the console view, and it's a CrossOrigin because I'm serving it at a different domain. And the way 3.js deals with that is if you don't have the CrossOrigin asset, it adds the CrossOrigin asset and downloads it again. So I'm just downloading all my images twice. So of course the fix there was to add the CrossOrigin element to all of my remote files. That solved that. So now they're all sized properly. They're all just downloading once. That's going to speed up the loading of the page. Other things I can do is when you change the quality of an image, you're removing pixels. In Cloudinary, the Q Auto tool, what that does is it reduces the number of pixels to where the human eye can't tell a difference. So I'm lowering the quality, but we as humans can't tell, so that's fine. It's just going to make the image smaller, but it'll still look awesome. And then I added a format auto so that it doesn't have to serve a JPEG. It could serve a WebP to me if I'm on Chrome or Firefox or Edge, just that other modern browser doesn't quite support WebP yet. And so I do all that with my Van Gogh, and it goes from 1.8 megabytes to 320K. Reasonable, right? That's a reasonable web page. Reasonable is probably still a little big. I felt it was a little big, so I went to 512 by 512, and I got it down to 93K. 93K, like, I'm totally comfortable sending an image on the web that's that size. So this is awesome. It's still going to look great, but I've made it, like, way smaller. Like, is that 1%? 1% the original size? Like, really, really small. All right, so GLTF models, I don't have an example of it here, but if you just Google Drako Compression, there are a lot of command line tools that will do Drako Compression on your GLTF files. And I got this down to like 2.7 megabytes, maybe 3 megabytes. That's 10% the original size. Still big, but if you want to do 3D models on the web, like it's just like putting a video on the web. You're gonna have to suck it up and it's gonna be a big file. But 10% of the original size is a lot better. I'm happy with that. So what's coming up soon, this is an old screenshot, but coming later this year is the WebXR API. Has anyone heard of the WebXR API? All right, so a couple nods, a couple people shaking their heads, but basically this is going to be built into the browsers, right? You can abstract it into things like A-frame, but this is going to be built into the browsers, and you can do this. It's going to be an API. This is obviously an old screenshot. It's from February. It's like, if it's not final, it's nearly final. It's going to be shipping. It's shipping in Chrome behind, not behind flags, but with tokens. Like, you can start building with this stuff. If you look at the screenshot here, it says unstable API. Anything you build is going to break. And so the example I'm going to show you won't work on browsers today, but it works with the very old version of Chrome Canary I have on my phone. This demo requires, just because it's a demo, it requires Android 8. It requires Chrome Canary from a year ago, like literally October of last year. You have to turn on a bunch of flags. You have to have AR core installed. Of course, if you want Chrome Canary that old, you can't go to the Play Store. You have to go to one of those sketchy APK download sites and sideload it and hope everything's fine. And then, of course, you get all this set up. You start playing with it, and that's super awesome. You go to bed, and the Play Store updates your Chrome Canary to the latest version, so you have to go do it again the next day. So if you're going to play around with this, I had to turn off auto-updating of my Chrome Canary so that it would work. What's really cool about this is that we're moving away from markers. It can actually, in the browser, determine if it's a horizontal or a vertical surface, and then you can apply things to those different surfaces, which is really kind of cool. So I've got a demo, and I'll pull out my phone, and we'll see if we can get it to work. I think this is the URL. All right. So here we go. This is my phone. And you can see it says experimental API, blah, blah, blah. I'm going to hit start augmented reality. That's not the right URL because it's not working. So we will see what's in my history here. Here it is. This is the one that'll work. All right. All right, so you can see it's telling me to move around. And why it's telling me to do that is it's trying to figure out what's, horizontal and what's vertical. Now you can see it's adding this little anchor thing. And if I tap there, it works some of the time. This is the Alpha API. Oh, see, I just put the Mona Lisa on the table, right? And what's cool is it sort of, there's a little bit of drift, but for the most part, it remembers where the Mona Lisa is. And then like maybe over here on this wall, we've got Starry Night. It went on sideways for some reason, but whatever. So we've got Starry Night there. The Mona Lisa is still there. And the middle tap is just a JavaScript counter. Screen was in the middle somewhere and it didn't work. So we can reload the page and try it again to get all three pieces of priceless art put up in in the venue, which is great. Like, here we go. Let's see. You can see the further away. See, for some reason, it thinks those are surfaces that are very far away. That's really close. So we'll put there's Scream right there in the middle of the right, and then we can put. Whoa. It looks like Scream moved there a little bit. The Scream's still over there. No, it moved. Oh, there it is. All right, but you get the idea, right? We've got this really cool thing where we can, we can add art in a virtual environment. And I bought this really long cord so we can see, we can go around the other side, see how far it drifts. Oh, it was this one over here. Oh, so I'm standing right in front of them. Wrapped in cables. But it sort of remembers where they are, and they sort of hang out in space. And that's pretty cool. I'm always a little hesitant using a €3 Flying Tiger cable for my live demos, but it seems to work. All right, awesome. I think that's super cool. So now we've got this way to add augmented reality right in the browser. It's all native code, and it works. When I built it, I was staying at an Airbnb that was all white walls, and it really didn't work very well because it needs to be able to find some sort of texture to find that if it's a vertical wall or not. So some optimizations that happened here is you saw this little moving thing telling me to move my hand around. That was an 850K animated GIF, and I hate animated GIFs. If you read the spec from 1990, it says, we have an animated format in the GIF, but we don't recommend that anyone uses it. Like, the spec literally says don't use animated GIFs. I always try to turn them into videos. In this case, it's transparent. Videos aren't transparent, so we have to stick with animated GIF. The anchor PNG was super huge, and we've got an off by one error, right? So we can fix all of this stuff. So first thing I did was let's only serve that much of the GIF, right? The rest of it's just wasted pixels and stuff. So I resized it just by getting X and Y's and making it 512 by 512, because again, it has to be a power of 2. And then I shrunk it down to 256 by 256. That took my GIF down to 174K. The PNG, I probably could have made it an SVG file, but I was trying to do this quick. With Cloudinary, I was able to make it 2.2K just by resizing it and lowering the quality. And that's fine. 2 kilobytes I'm happy with. What's really awesome is that demo I just did for you loads in my browser in 600 kilobytes. Right? This is not something that's going to generate a lot of data. I could actually load this page almost 25 times on the GWR on my way over here, right? Before I get throttled. The average mobile web page is 1.7 megabytes. We're building augmented reality in the browser for way less than that. And for me, I think that's super cool, especially when you think about easily a third of that is that stupid GIF, right? The augmented reality is taking up no data at all. And I think that's really awesome. So we have this ability now to reach, with augmented reality, millions and millions of users, because people who have smartphones and have browsers, every single smartphone has a browser, and this stuff is going to work. And to me, that's really exciting because, we haven't really scratched the surface on what we can do with augmented reality in the browser, but expect it to be coming soon because there's so many fun things we can do, and it's going to be available for everybody. So in conclusion, we can do it today with A-Frame. The WebXR API is coming later this year. It's around. And what's great is almost anyone can do it. And it's immediately available to millions and millions of people. It's not processor intensive. It doesn't use huge amounts of data. You will notice if you leave your phone open with the camera on for a long time, yeah, right, it's warming up, but that's just because the camera's running. But I think this is really, really cool. So with that, thanks everyone for listening. Later this afternoon, we're going to take some of this stuff and we're going to build. So if you want to come and build, we're doing a workshop later this afternoon. We can build stuff with A-Frame and augmented reality or virtual reality. Thank you very much for listening. I appreciate it.